In the diagram below, measure of angle 2 is 95 degrees. So we're going to find angles 1 and 4. And the first one that I'm going to look at is angle 4, because this angle and this angle, so angle 2 and angle 4, are vertical angles. And consequently, the measure of angle 4 is also 95 degrees. But when we look at the measure of angle 1 here, what's going to happen is we're going to take the measure of angle 1 and we're going to add it to the measure of angle 2. And what we're going to end up with is we're going to end up with 180 degrees. And if you notice, if I draw this in, it looks like a protractor, and a protractor has 180 degrees in it. So instead of calling it the measure of angle 1 here, when we saw that, I'm going to call the measure of angle 1 x. We know that the measure of angle 2 is 95, and that equals 180. So we're going to subtract 95 from both sides. We end up then with x equals 85 degrees, and that's our measure of angle 1. Using the diagram below, find the value of x. Well, same idea here. If we take these two angles and we add them together, they're going to add up to be 180 degrees. So we took the red angle and we added it to the blue angle. And when we add these, they form a straight line. And then we can combine like terms. 2x plus 4x, 6x. 24 plus 36 is 60 equals 180. And then we can subtract 60 from both sides. So we end up with 6x equals 120. And divide both sides by 6. So x equals 20 degrees. I think that's what we want to find. Find the value of x. Number 3, find the value of the missing variable in each diagram below. Assume lines that appear parallel are parallel. So as we take a look at this, one thing that I just want to point out on letter A is that we have same side interior angles. And you might want to go back and look in your notes. What is a same side interior angle? But as we solve this one, what has to happen here is we're going to take x plus 31 and we're going to add to it x plus 25, because same side interior angles add up to be 180 degrees. Don't forget that the number from these x's are 1s. You might have forgotten that. But when we combine like terms, 1x plus 1x is 2x. 31 plus 25 is 56, and that equals 180. We can subtract 56 from both sides, and when we do, we get 2x equals 124, and when we divide both sides by 2, we get our value of x, which is 62. The key on these types of problems is being able to recognize what kind of angle we're working with. And on this next problem, what we're working with here is we're working with alternate interior. Oop, I better write underneath. Alternate interior angles. And what we know about alternate interior angles, see how they're in between this line and this line, and then they're on opposite sides. That's what an alternate interior angle is. And what we know from those is that we can take the 10x plus the 2, and we can set it equal to the 12x minus 8. Alternate interior angles are congruent. Solve this the way your Algebra 1 teacher taught you. I like to move my letter to the left We're going to subtract 12x from both sides. We get negative 2x plus 2 equals negative 8. We can subtract 2 from both sides, and we get negative 2x equals negative 10. And then finally, we can divide both sides by negative 2, and x equals 5. Number 4, on the following road map, Lakeport Road is parallel to Marina Road. If measure of angle 1 is 72 degrees, what is the measure of angle 74? And this is a multiple choice question. The thing is, as we take a closer look at this one, what we've got is that this value is 72. And if we look real close here, the thing is that angle 2 is also 72 degrees because it's a vertical angle. And ultimately what we're trying to figure out is, well, how big is angle 4? Well, 72 is underneath Lakeport Road, which is parallel to Marina Road. Number 4 is underneath Marina, which means that 4 is also 72. Those are corresponding angles, and corresponding angles are congruent. In the figure below, A is parallel to B. If measure of angle 1 is 2x plus 30, and measure of angle 2 is 6x minus 30, what's the measure of angle 3? Well, again, we need to know some relationships within this, but measure of angle 1 and measure of angle 3 are corresponding angles. They're both above and to the left of the transversal. This is the transversal. So they're in the same position. So that means that if measure of angle 1 is 2x plus 30, then the measure of angle 3 is also 2x plus 30. And now, when we take a look at this, measure of angle 3 plus the measure of angle 2 forms that protractor again. So what we can say is that the measure of angle 3, which is 2x plus 30, and the measure of angle 2, which is 6x minus 30, they have a total value, when we add them together, of 180 degrees. And if we add like terms, we get 8x. Positive 30 and negative 30 cancel out, and this equals 180. And when we divide both sides by 8, use Desmos, use your calculator. I don't have my calculator open at this point, but if we take 180 and we divide it by 8, we end up with 22.5, and sure enough, in the diagram below, line L is parallel to line M. QR is perpendicular to ST at point R. If measure of angle 1 is 63 degrees, we want to know how big measure of angle 2 is. Well, the first part that we need to notice, again, this line and this line are parallel. So in between here is 63. This is also going to be 63 because it's two lines cut by a transversal. Alternate interior angles are equal. So what we're really specifically looking at now, that we're able to identify that 63, is we're looking at this triangle, which I covered it up, but it's a right triangle. So what we know in here is we know 90 degrees, we know 63 degrees, and if we add that together, we get 153 degrees. a triangle has 180 degrees, and if we subtract what we already know from it, the 153 degrees, we should get 27 degrees. Number 7, find the value of the missing variables in the diagrams below. So as we take a look at this one here, it's same kind of idea in some regards. We need to figure out something about this triangle, but one of the pieces that I noticed right away is that this length and this length are congruent, which means that we're working with an isosceles triangle. And consequently, in an isosceles triangle, if we've got two congruent sides, this angle and this angle are also congruent. And we can figure out how big angle x is if we take 125 plus x. It equals 180. Subtract 125 from both sides. And when we do, we get 55. So now we know this is 55. And consequently, that means that this is also 55 because it's an isosceles triangle, and the base angles of an isosceles triangle are also congruent. And we can take 55 plus 55, and we get 110. And then we can take 180 minus 110, and we get 70 degrees, which is how big y is. We actually have found x. Now we know y, and then we want to finish by finding the value of z. Well, again, and my picture's pretty jumbled up, but this and this had to be 180 degrees. So if we take 55 plus z equals 180, and we subtract 55 from both sides, we end up with z equals 125 degrees. So again, x, y, and z. Look at letter B. Letter B, this particular triangle, EQUI, is an equilateral triangle. We see that each side length has the same value. And remember that in a triangle we have 180 degrees. And if all three sides are the same length, then all three angles are the same length. So if we take 180 degrees and we divide it by 3, we get 60. And you didn't necessarily need to do that if you knew that in equilateral triangle, each of the angles is 60 degrees. Because once we know that, we can set 6x equal to 60. And we can divide both sides by 6. And when we divide both sides by 6, we get our value of 10.